Hi guys, and welcome to one more tutorial of Minds of Machines. So what if you could build your very own AI agent, not some science fantasy, but a real assistant that soars the internet, finds the answers, and even tells you where it got them? That's exactly what we are going to do today. We are building a smart research agent using Tavily Search API, and it's a way simpler than you think. But first, before we get into the how, let me show you what this little brainy agent can do. Now let me show the demo of my research agent, which is powered by Tavily Search API. So here I will have a research topic section where you will enter your questions, and then I have provided two options. Then I've told you what my agent does just for the user to know, and then there's a search history. Finally, I'll be now showing you when I ask it what is AI. It will, in an advanced mode, it will do the research and it will show me the first five research or the main topics for this AI related things, and it will also give you the hyperlink with the definitions. So you can click and then it will take you to that particular page. So this is how my research agent will work. And next, I'll also show you how my search history will look like. So what I will do is I will write one more question, basically, like what is agent in AI, and then I'll click the research agent. It will show me what an agent in AI means. Within summary, an AI agent is blah blah blah, and then it will take you to that particular page as I clicked it. And finally, when you click on the refresh button, it will show what I have searched in the past. So this is what we are going to learn today. So now let's get into the code part. Now let's understand our AI powered research agent built with Tavily step by step. So first I will be working on the backend, that is the where the real magic happens in the API.py file. Then I will show you how the front end and the backend connects with the simple service API by like passing a notes between two friends. After that I will show you how the data is loaded in the front end file, and finally I will show you what each components of the React does. So now let's get started and break it all down piece by piece so you can build your own smart research agent, do that to free of cost using Tavily API. Now let's start at the front end part. So first we will be focusing at the components which I have built to bring the UI. I'll just give you the overview of how each component works. So first is the about section. In that, it's like a welcome board of a smart research robot. It tells you what the robot can do, like searching the internet, summarizing the answer, and giving you the helpful links. And it also searches the cool tips on how to ask better questions, like being specific on checking different resources. We have added the fun icon to make it look friendly and clean, like a digital poster with super powers. Basically, it's like a robot's intro page that helps you get the better results from your search adventure. Then next is the header part. It's like the name tag at the top of your app that tells you everyone what it is. It shows the big title like research agent in bold, so you know what this tool does. And right below it says that Tavily, which is a super smart search engine we use, and it's a simple clean and always at the top, so you know where you are. Think of it like a title screen of a game, short, sharp, and welcoming. Next component is the history items. It shows a saved search from earlier, like a bookmark for your past questions. It displays the questions you asked when you asked it and a short preview of the answers. There's even a tiny clock icon to show the time, which makes it feel like a digital journal. When you click on it, it loads that search again, like reopening a favorite book page. It's clean, clickable, and super useful for remembering what you explored. Next is the history section. It shows you all the cool stuff you searched before, and it has a tile with the little clock icon and a refresh button. When you click, if you want to get the newest result, if it is loading, you'll see a spinning animation like the robot is thinking. Once it is ready, it will show you the old request neatly in the boxes using history item. Basically, it is your AI search diary, one click, and you can retrieve your any past adventure. This is the result sections. It shows the answer of the AI found for your questions. If the robot is still thinking, you'll see a loading spinner and a massage saying it's working on it. And once it's ready, it shows you the nice summary of what it found and a list of trusted sources. For more info, at the bottom there's a new search button, so you can ask a brand new question. Think of it like a digital report card, clear, smart, and ready to explore again. Then there's a search box where you uh, ask your big questions to the smart AI helper. You type your topic, pick how deep you want it to search, and hit the button. If it shows a loading spinner while the AI works, even gives you a heads up if you forget to type something. It's like the magic doorway where your question starts and its journey to find the answer. Next is a source box, and it shows where the AI found its information, and it gives you the title of the page, a link to click, and a read more, and a short preview of what inside. There's even a tiny arrow icon that tells you this will open a new tab. The box changes color a little when you hover, like you are saying click me, and it's like a treasure tag that says here's where I got my answer, go see for yourself. So this is the overall front end component. I've just given you a gist of what each component does in our web page. If you want more details, I can discuss how the React component is built. If you comment in the section React, then I will let you know what new things, how you can build these React components for your own website. Now, let's first understand the main heart of this web application for AI agent, in which first we are going to create a file inside the backend folder, inside which we will be defining the file called as app.py. So this Python code in which we are going to write inside this file builds a smart robot that can search the web when you ask it a question. It remembers your past questions, shows you your answer, and links and talks to the front end using special door called API routes. It is like having a research assistant that lives in your computer. So first, for that, we will, as I said, create the api.py file by creating inside the folder called backend. Then we are going to import the libraries which we need to build this app. That is, we are going to import the Flask request, JSONify, and send from directory from the Flask library. So the Flask starts our website server. The request reads what people ask, JSONify sends the answer back as clean JSON, and send from directory lets us give files from folder. Next, we are going to import the Flask, the basically the Flask cores, or the cores from the Flask core library. This tool is to make sure our website can talk to each other like your front end, otherwise it will block it since we are developing it on the local system. Without this, they cannot share the cookies or data, so it says the server not found when you run if you don't use the cores, if you're building your apps on the local server. Then we are going to import the OS. This helps us talk to the computer environment like grabbing secret key from the e.env file. So basically you can't keep your API key in an unsecured environment or it gets hacked. Then some other people can use your API key. So in that case we keep it in a .env file, which is more secure. Then we use this library called as load underscore .env from .env libraries. That this tool is basically used to open the .env file and load the secret key in our app. Then next we import the JSON. This lets us work with the JSON, a format that looks like lists and dictionaries and is great for sharing data. Then next we do is import the Tavily client from Tavily. This is a AI web search robot, and it helps us to search the internet and bring back smart answers. Then next is loading the environment file, is to load all the secret inside the API key. After that we get the API key, and this is done by os.getEnv, inside which we define the API key. That is basically to get the API key from our secret stash environment. After that we define the Tavily client. Now we have to connect to Tavily using the secret key so we can ask it questions. So we basically you connect the Tavily using this key so that we can ask a question. After that we start the Flask app. The Flask app is basically app equals to Flask, inside that bracket we write name. This starts the app and the things that listens for web requests. So basically it's building from where you start building the Flask web applications. Then next is you define the cores bracket app comma resource, and then you put all the local host and the methods which you want, and also allow the header context. So we are telling our app it's okay to talk to our front end, probably React, running on the local host 5173. This needs to avoid cause errors when React tries to fetch data. Basically, whenever it gets any response from the Tavily, it should not face any cause issue based located on this local host. Next, we are creating the AI agent class. So we are building a custom robot helper that will do the research, that will do the searching for us, basically. So that's why we are defining the class called as research agent. Then we define the init function and name it as a research agent, in which we set the name equals to name, and then search history equals to an empty array. This is a setup part. We give the agent a name and a notebook to keep a track of everything which we search for. Then next is we create a search function. This is the main brain function. It takes the question as query, and how deep it should search is the depth we have defined, called as search depth, as a parameter in a function. Next we are going to call the Tavily client search functions, which will give you the query you pass, the search depth you send. Then it will include whether you want to include the answer, whether you want to include the image, so you can set it as false, and the max result should be 5. Our means first 5 results we want in our response. It's basically writing an wrapper class around a you can say around a LLM, so that it can act as an agent, and it will give you five smart answers, no pictures, just summary. Then we are going to create one more function called a self dot sorry, not function, self dot search history, and append the query, the timestamp, and the result to it. So basically we're writing down what we searched, what answer we got, and so what we can show as history later. Then we return the search history, so we send back what tell we gave us. Finally, we throw an exception if something breaks, like no internet, we return an error message. Finally, after that we process our result. So we create a function which can clean up the result so it's easy to display. Then we, if Tavily fails, in that case we will return summary as error, no result found, and source as empty. And what exactly error happened, we send it as error, unknown error. We need to send back a message saying something went wrong so that the user knows. After that we define a summary in which we call the main answer, that summary from the result, where it sends answers and no direct answers found, gets basically the main answers from the result. After that we declare a source, for source in search results to get the basically we define a source array, and then we do a for loop on the source in the search result to get the result. So basically we are trying to loop through each result and grab the title, URL, and a preview. After that we are trying to do a source append, that is title and URL and the content. So basically adding each cleaned result to our list of source, showing the first 200 characters, basically that one. And then finally we return a clean final package with summary, source, and the time it was searched. In the inside the return command, summary equals to summary, then source equals to source, and query time is equals to the search result which you get in the form of metadata and time. After that the agent method is combined to everything. So basically what we do, we create one more agent, that is the research topic. We also pass a self topic depth advanced, and this is the main entry point, take a topic and depth and does the search and cleans it up. So what it does is, first we search the, then process the result. So we search it using cell search, as I showed the function how we write the topic and the depth, and then we process the result by what response you got from the search result. After that you return the agent name equals to the name what you get, topic, the depth, and the result process. So returning everything as one nicely format object for the front end. Next, we are creating a robot helper from a research agent class. So, which is basically research agent equals to research agent. We are basically calling the robot helper class here. Then we are creating the API route. So, basically, if someone sends a post request to research, we handle it here using API at underscore API dot root bracket / research comma method and then post. Inside this API, what we write is, we define a function called a search topic. The function is called when we receive the search request from the front end, and then we put the data in that folder using request.json. Then we put the topic and read from that particular request where the topic is sent. Then we read the depth in the API, which request API which we have got, and we pull out all the topics and depth from the front end. Next, what we do is, if the topic is not found, then we return JSONify no topics found 400 we throw. And if it's basically a very bad request, in case it's not giving you any result, basically the connection is working but you're not getting correct response. Next we will next line we have written result equals to research agent bracket dot research topic, in which we send the topic and depth that will give us, as I showed the previous logic where we have created the function and how it gets the response, and then we store in the result, we convert it into the JSONify. So we basically ask the robot for the result and then we return them as JSON to the front end. After that we create one more request. This is the same thing as research but under API search, helpful for front end API. So what we do is we create, basically it's does the same thing as search but a slight different but helpful for front end APIs. Next one we have created, basically it's for the advanced level search. It first is the there were two search options which you saw in the depth. One is normal, one is advanced. So we have created the same thing. It does the same as above, just the depth is different in this case. Next we are going to do is we are also going to create one more API for history, and this method will be get. So these and slash API slash history, basically slash history, these two routes let people get the search history as a list. So here you will get all the search history which the agent has done or you have done, basically uh, through the request. And then finally inside that we create a function called get history, and it sends you the research agent dot search underscore history, the search history function which we wrote previously. Whatever result that gives, we return through this API. Then finally this will show all the past questions which we have asked the robot, basically. Then finally we will create at the rate app dot root bracket forward slash and then def home bracket, and then inside that we'll write return the research API is running and the user slash research query or API slash history or all the APIs. This is basically to signify that the APIs are running when you are starting the server, so that you know that your server code is running. Basically make remember that when you are running the app, you have to use two terminals, one for to run the front end and another to run the back end. If you don't run the back end, you won't be able to connect it to the back end. Then what we do is this home root, if you visit the root page, it shows as a welcome message. So this is basically to check our API is working fine or the server is basically working fine. Then we are going to define if name equals to main. This is basically checks if the file is being run directly, like saying are we starting the show now, and then we are defining the port. We check if there's a port set in the env. If not, we use a port. We need a port to run our basically backend. And finally we start the server on the chosen path. 000 means accept request from anywhere, and debug equals to true means restart the server automatically when we make the changes. So the app.run bracket host is basically telling you that you accept the request from anywhere. True means restart the server automatically when we make the change, so you don't have to switch it off and switch it on. So this is how the entire backend part of an agent is written when you are using any wrapper classes. Apart, if you are using any other crew AI agent or Tavily or any other things, you can write the code in a similar format for backend. So now I have created one more folder, as you can see, inside the front end called a service. Inside the service I've written as api.js. So basically the api.js file is like a walkie talkie between our website and the smart backend robot. as a front end needs to show basically what our backend is doing to the user or the AI agent is sending us. So that's why this api.js file comes into picture. It helps us to send a new question, gets the answers, and looks back at what we asked earlier, all using Magic Messenger powered by Axios. So first, we will create a file called as api.js in the service folder. Then what it does is we are basically first importing the Axios from the Axios library. uh, the Axios is a library that helps us to make http requests, like talking to a server. Then next, it's like bringing a robot messenger who can ask the backend question and bring the answer back basically. Next, we are defining the const called API underscore base underscore URL, in which we are defining the local host 8080, which basically sets the URL where our backend server lives, and this is the base part for all our requests. We are telling our robot where the big computer brain lives, like giving it the address of the research robot. Next, we are going to define the parameters in the comment part. It's basically comments which we write in the JS file. If we want the developers to understand what exactly we are doing it. So for that explains what the search topic function does basically, is using the research agent and what parameters it expects. Like the parameter string topic is the topic to research, then parameter string depth is the depth, is it basic or advanced, as we have two function which we saw in the backend, basic, and one we have written for advanced version. Then next we have the search result finally, which returns the basically in the form of object the search results which we want to show in the front end. So this basically is comment that explains what the search topic function does and what it expects. Next is the export const search topic is equals to async, because asynchronous communication is happening. We don't want synchronous, or the performance of the web app will be slow. So we will be having topic depth as advanced, in which it basically we are creating a function called search topic, making an async call. So we use await inside, and it sends a question to the backend, and this is to ask the robot button. You give the topic black hole and it goes searching. After that, we define the try function, in which we call the axios.post, in which we send the API base URL which we declared previously, and we call the research function which we defined in our backend, inside which we will pass the topic and the depth, whether we want basic or advanced level. Next, we are sending it in the form of post, as we are sending a large amount of unique data. So post is basically you're not sending in the URL, you're sending inside the request of the body. Then we are returning the response which we get from this API call which we have made. So that it returns the actual data to the front end from the back end in the form of answer, summary, and source. Then what we do is, then we since we wrote it in the try catch, it helps basically to catch any exception occur. So it's a coding practice where we write the try catch thing. So what it does is it will catch the error and show in case of error search string topic. If the agent is not able to perform, then we get a proper error thrown that okay, our agent is not giving us proper answer. Then after that, next we have set this one comment called as get the search history, because we are also going to show our front end user the search history. So we have also a search history API. So here what we are expecting, we are writing in a comment that get search history, and what parameters it will be sending in the form of object is the search history. It's what we have done in past. So after that, we will create export const get search history, inside which we will write the async function, and this will basically create a function that fetches the search history from the backend. And then we will write a try function, inside which we will get the response by using the Axios library, in which we pass the base URL /history. So what it does is, it is basically gets the request to the history and returns the list of old searches. After that, we are going to catch the error from the try, so that we know that our search history API is also not working. If something goes wrong while asking the history, it logs the error and throws it back. Finally, this is how the API you can call when you are communicating the React component, that's a front end, with the backend by using the access library. And this is how you access your backend functions via front end. So now let's understand how we are using it in our front end components. Now let's understand how in our app.jsx file, which is the main file where we declare all our components, and that's the main framework for our front end, and how we read the data which we got from our api.js file in the components, and how we pass to these components, we'll understand at this part of the code. So this part is basically about keeping track of what we searched before, showing answers when the robot finds them, and letting us clear things out when we want to ask something new. It's like having a smart friend who remembers your old question, gives you new answer, and helps us reset everything with one click. So I'll just show you the main part, not go in detail explaining each part of the component functions. So first, we are using the use effect function of React. This is a React hook that runs some code after the component is loaded. So components are basically the UI parts of the React. So it will run some code, that is this part of the code which is written inside the use effect, after all the component is loaded, so that our data is shown after we see the main components, which I will be talking after I finish explaining you this part of the code. So this first, we have inside that use effect, we have written load search history function. So this will load the search history data after my component is loaded basically. So uh, this means, and there's a square bracket which we have written inside that. This means it only runs once, just like the component did amount. So the bracket shows it will only run once when you execute this file. Next, we are going to load the search history in async format, and then this is basically a synchronous function. It is marked asynchronous because we are going to use a wait, which means it waits until something is ready. So we are making our helper that says go ask the robot what we searched before. Next, we are going to load the search history loading function. We basically, this function will load history state to true, and this can trigger a spinner or loading messages in the UI. After that, we are going to do the try. We are going to write a try which will get inside this, we will get the data. We are trying to create a try block, and we wait for the API call get search history to finish, and if successful, it gives us the data from the backend. Then we are going to pass it to the search history data dot history. We take the history part from the response data and update the React state with it. If it's missing, we just use an empty array. Then next, we are defining the catch error. Basically, then we are writing the console dot error. Basically, it should show if the server is down, we catch that error and print it in the console. After that, we define finally, then we inside that finally we write set history loading false. This block always runs whether the request worked or failed. It turns off the loading state basically. It's like turning off the loading light whether we found the notebook or not, because initially we will be showing loading. At some point we have to stop it, so we are using this. Then we are going to define constant handle search success, inside which we are going to set the search result. Basically, this function is called when a search is completed successfully, and it stores the new result in the search results. This line does. Then we are going to define a handle new search function, in which we are going to set the search result as null and window.scroll top equals to 0, behavior smooth. This means that the current search result is set to null and smoothly scroll the user to the top of the page. So this is the entire part how we load our data, which we get from the server, from the api.js file, which gets the data from the api.px file, which is in the backend folder. So the api.jx is a front end, api.js is the middle person, and I mean basically the one which is inside the service folder, and the final backend is the api.py file. So this is how it is connected. Thank you so much for watching. I hope this tutorial helped you understand the concept clearly. If you found it useful, please give it a thumbs up and don't forget to subscribe to the channel for more content like this. Your support really helps me keep creating helpful videos, so see you in the next one.